Hey everyone, how's going on? Welcome back to another video, and in this video we are going to learn how you can create a object detection Android app. So the idea is very simple. We are going to use this model and the input will be the image and the output is going to be the bounding box around the object and the class or the label of that particular object detection. So we are going to build this app in this video, and if you are interested in making something like that, so welcome. First of all, we need to download the starter model with metadata, so you just click on this download the starter model, and I will leave the link to this page in down description. Now our work over here is done. Now let's open our Android Studio and start by creating a new app. Alright, so here is our Android Studio. Let's create a new project, then empty activity, and let's give the name. Let's just say object ml app and hit enter. The language I'm going to use is Kotlin language. If you want with Java, just let me know in down comment section. Well, there not be a much difference. You can just relate different languages, but if you want with Java, just let me know in down comment section. I will make one video for that also. Alright, our Android Studio is now ready. Now it's just ready to write our code. So first of all, let's get to our UI part. We are going to create very simple UI. So UI wise, I'm going to use a relative layout like that, and we are going to have a image view. So let's just create a let's have a image view, and it will be match parent. Height and width will be match parent. Let's give id as image view, and let's just give a background also to it, just to see everything is going on fine or not. And other than that, I guess everything is fine. And now we are going to have a button, so let's just give a wrap content, and let's just give it a text. Let's say select image, and it is going to be attached to bottom, so layout bottom true, and let's just align center horizontally. Let's make it true, and let's just give a margin bottom of, let's say, 20 dp, and I'll just also change its background tint a little bit. Let's just say black for now, and for image I will just make it this color, and for button I will make it with this orange color. Okay, let's just change this one. Okay, this is our UI. If you want to change it, just go on with it. Now the main game begins on main activity.kt. So let's just first declare our button and image view real quick. So here we have a image view and also the button, and I'm going to also use a bitmap variable to store the image. You will just see where we are going to use it. For now, let's just declare it over here. Now let's initialize our image view. Image view is equal to find view by id, r.id.image view, and similarly button is equals to find view by id, r.id.button. I forgot to give the id to the button, so let's just give the id, let's say btn real quick over here. Now let's get back to our main activity and just say button. Now the main idea is when the button is pressed, we want to open the gallery and just allow the user to select the image from file manager. So when the user selects any image, we will use our model to detect the location of the object and just draw the rectangles and prediction on that bitmap. So let's just do that thing. First of all, when the button is pressed, we are going to say set on click listener. So when the button is pressed, we are going to use the intent. So let's just say let's just define the intent over here only. Let's say value intent is equals to intent to import, hit option enter, and now intent. Okay, so here is our intent. Now let's set the type of our intent. So intent dot set type. So the type is going to be image. So the type of the data we want to show to the user is the image data. Now finally intent dot set action. So the action is going to be action get content. So intent dot action get content. That's it. Now when the button is pressed, we want to start this intent. So we'll say start activity for result and just pass this intent over here and just give it a code. Let's say 101. Now out of this, when the user selects any image, one callback function is invoked, which is on activity result. So we just override that function like this. Now over here we are going to first check if the request code is equal to 101, which we have passed right over here. Now if the request code is that, we are going to use this data to take the image from that whatever location over here inside this data. So first of all, we need to fetch the location. So we'll say where URI, which is uniform resource indicator, and you can say data. Now inside this URI, it is the location where the image is located. So we need to access that image and store that image inside this bitmap. So that's why we have used the bitmap variable up there. So we'll say bitmap is equals to media store dot images dot media dot get bitmap, and just have to pass the content resolver, which is this dot content resolver, and pass this URI just like that. Now we have the bitmap inside this bitmap variable. Now once we have the image, we want to run the prediction on this image, right? So we'll just create a function get prediction. So we'll just write this function get predictions. So fun get predictions. Okay, so alright, now is the time to import our model, so which we have downloaded. So for that, you just have to click on file, new, and just go below, click on other, and we have to say TensorFlow Lite model. Now you have to click on this folder icon over here and locate the model wherever it is located. In our case, it's this ssd_mobilenet model. So you just hit open and hit finish. That's all. Now let's just import the labels.txt also. With this model, you are not going to get the labels.txt. For that, you can just go below in down description. So you will just get access to that labels.txt from there. So for copying the labels.txt, first of all, let me just show you. Alright, so here is the labels.txt which you can get in down description. Link will be there. So just copy this and get inside over here. You can just click on this project and then project over here. Now go inside app source main and create a new directory. And you can name this directory assets. Now inside this assets, just paste this labels.txt file. Let's just change it back to Android. Okay, now once our model is loaded over here, you can see it over here. If it is not opened automatically for you, you can just go back to this project, then ML, and double click on this, and you can get access to this code once again. So I'll just copy this code and paste in our get prediction function for now, and let's hit option enter wherever you're getting this red mark. For tensor image, option enter, and instead of this context, we'll say this. Now I'm going to declare this particular initialization of model up here. This will be my model. So since I want to access it globally, so I will just say late init where model. What is the type of it? It is this type. And instead of closing the model over here, I'm going to override a function which is on destroy. When the app is closed, then I will close the model. So I'll just get rid of these comment sections also. Alright, so everything looks fine. Now it's time to load our labels.txt also. So for labels.txt, I'll just do the same. I'll declare, let's just get it over here only. So we'll say value labels equal to, so this time we are going to use file util. Don't use this file utils. You are going to use file util, hit dot, and if you are getting this import error, hit option and enter. This file util is from TensorFlow given to us, this over here you can see. So we are going to use file util to open our file util dot load labels. Now you have to pass the context, which is this, and then the name of the file, which is labels.txt. This is going to return you a list of all the labels with the particular index. So this is how you can read the labels.txt very easily by using TensorFlow. Alright, everything looks fine. And now the only thing we need to change is that this model expect the input to be in the shape of 300 by 300, but our bitmap which we are passing over here could be of any size. So we need to resize this image or this bitmap. We have two options. So I'm just going to resize this image with the help of image processor, which is again provided to us by TensorFlow. So I'll just say let's just say val image processor equal to image processor. So let's just import it, option enter, and we are just going to say builder dot add, and we are just going to add resize op. And if you are getting import error, hit option enter, and height and width will be 300 by 300, and method will be resize method will be bilinear, and just dot build like this. Now we are going to use this image processor to resize this image, so we need to convert this to var. We'll say image equal to image processor dot process, pass this image like this. All right, looks fine over here. Okay, it should run fine up till over here, but we are not showing the predictions anywhere, right? So we need to use these outputs in order to show the predictions. So first of all, these are load buffer, so we'll just convert them to float array so that we can access them easily. So all of them like this. Okay, now let's have a look at the outputs, what the output look like, which we have over here: location, classes, score, and number of detection. So let's just get back to over here. So first of all, number of detection is the number of objects it is able to detect in the image which you have passed. This will be a single value. This is not going to be a array. Now second, we have the classes. So the classes is basically the idea of all the objects it has detected inside the image which you have passed. So this is going to be a array. And scores is the confidence of every object which it has detected, and location is self-explanatory, but it is the location of the object inside the image. We'll use these locations to draw the rectangle. We'll use these classes to get the id, to get the name of the object it detected by using the labels which we have imported, and this scores we are going to use to get the confidence of that particular detection. So let's just do the same, use all of these outputs in order to draw on our image on our bitmap. So for drawing, we are going to use canvas and paint. So let's just go to the top over here and define the paint value, paint equal to paint, just like that. And other than that, we are going to use the canvas, so we'll say value canvas equal to canvas, and we need to pass the bitmap to it. So I just hit import. Now if I pass this bitmap like this, it is going to give me an error since this bitmap is not mutable. So we need to create a mutable bitmap. So I'll just say mutable over here. So for creating a mutable bitmap, it's very easy. You just have to say where mutable is equal to this mutable, the name of bitmap. So we are just going to say bitmap dot copy, and then configuration will be argb 8888, and it will be true. Is mutable will be true. Now this mutable I'm going to pass to this canvas, and on this canvas you can just use the features like draw rectangle, draw text, or put text, and there are a lot of drawings you can do on this canvas now. So now let's just iterate inside this scores. So I'll just say scores dot for each indexed, this one I'm going to say canvas dot draw rectangle. But before we draw, let me just tell you that these locations contain the location normalized value from 0 to 1. So we need to scale this value to whatever height and width of the image is. So we need to get the height and width of the image also. So we'll say value height is equal to mutable dot height, and value width equal to mutable dot width. So we'll just multiply with height and width to scale the image. And other than that, I guess everything is fine. I'm going to use x variable also. Let's just, okay, so you will see if x is forward, but for now let's just say x is equals to index over here. And now we are going to say if fl is greater than 0.5, since we are iterating inside this score. So if the score is greater than 50%, then only we are going to consider that as a good prediction, right? So we'll say draw rectangle, canvas dot draw rectangle. So it is going to take the rect f object and paint we have it, so it's just this paint. Now it need a rectf object. Now this rectf need 4 coordinates, the top left right and the bottom right one. So it need 4 coordinates, which we can get from these locations. From 0 1 2 3 is the location of the first object, then 4 5 6 7 is the location of the next object. So we are just going to say x over here, and from these locations we can say locations dot get. We are going to get x plus 1 first. It's just how it stores the value. So locations dot get x, then we'll say locations dot get x plus 3, and then locations dot get x plus 4, sorry, x plus 2. So 0 1, then 2, and then we have 3. Now I'm going to scale them. So this is my x value, so it will be multiplied by width, and the other value will be multiplied by height. This is I guess the left one, so multiplied by width, and this is the top one, so multiply by height, and similarly multiply by width and multiply by height. That's it. One more thing, actually, this paint is going to draw the rectangle filled one. We need to draw the rectangle stroke one, so we'll just set the style. So style is going to be is equal to paint, actually, style dot stroke. So we need to draw the outlined rectangle, not the filled one. Now we are going to draw the class, whatever the class of that particular detection is, and as well as the confidence associated to it. So again, I'll just change the style to filled one, since we need to write the text. We don't want a stroked text, we want the filled one. So we'll just change it to fill. So now we say canvas draw text. So it need the text xy value and then paint. Text will be inside the labels, and we want to get from the labels we want to get the classes, and from the classes we want to get this particular index, and this is a float, so we'll just convert it to int. Now it need the location, xy location, and then finally the paint. So let's get the xy location. Xy location is going to be the same, this one. Okay, so it is only going to write the label of it. We also want the confidence, so we'll just get this fl value like this. I'll just convert it to string just to be safe. Okay, I guess everything looks fine and it should run fine, except one, which is this x. So this is equal to index, so index is going to be 0. For the first case it is going to run perfectly fine, but when the index will be 1, x will be 1. So here you see 1 2 3 4. So we don't want 1 2 3 4. We have already 0 1 2 3. We have already used 0 1 2 3 initially when index is 0. Then we want 4 5 6 7, right? So we will get the x like that, and we will multiply by 4. So when x will be 1, meaning when index will be 1, it is going to start from 4 5 6 7. When index is 2, so it will be 4 times 2, which is 8, then 8 9 10 11, right? I hope it makes sense. So now I will just check once again if there is any problem or not, and then we are going to run our code. Okay, our app is crashed. Let me just check what is the problem. It says that attempt to invoke virtual method on resources, and my guess is that this line might be causing the error. So I'll just comment this line for now, and for the labels I'll just get rid of this for now. Let's try to run app once again and see if that is the problem. Yes, that was the problem. But why? So fileutil dot load labels, this dot path. Okay, so I'm thinking let's just say late init where labels over here. So I'll just define these labels down over there, but wait a minute. So I'll just redefine this thing over here, and instead of saying this, I'll just say late init where like this. I will copy this, remove this, and it is going to be a list of type string. And on create function here I'm going to define this, and hopefully this would solve the problem. Let's run this once again. Yes, our app is running fine now. Okay, so let's try making some predictions from our app. So I'll just click on select image and let's select this for okay. I'm sorry guys, actually one thing I forgot. We are drawing on the image but we are not showing it on the screen, so we'll just say image view dot set image bitmap and it will be a mutable. Let's run this once again and this time it should solve the problem. Alright, so let's click on select image once again. Let's select this one. Okay, actually it is detecting something. It says apple. Let's try to give this, and it says dog, but the problem is this font size, everything is so small. So let's just solve that problem also. So for that, it's not that difficult actually. We are going to access the paint one. So paint dot, actually first of all let's say text size. So the text size is going to be, let's just make it proportional to the height if possible. So we'll say height divided by, let's just say 35f. And similarly this is the rectangle which is the stroke width. So paint dot stroke width is going to be height divided by, let's say 85f. Let's run this once again and let's hit select image, and this time again dog. The stroke is fine but the text is still small. Let's just say 15f. If let's again select image and let's select the dog. Okay, dog with 76% accuracy. Everything is looking fine right now. Let's select this apple. It says apple with 71% accuracy, fine. Let's select this border. It says 82% accuracy. Let's try this one. Everything it says that person. It is detecting person, fine. And let's select this one. It is detecting it as book, and this has cell phone, and this has mouse. Now I'll just make very small difference over here. Okay, so what I have done, I have created list of colors. So for every prediction here, for every drawing we are making, I'm going to set the color paint. So I'll say paint dot set color. So the index will be the, sorry, not the index, actually colors is the name of list I have created, and get the index value from it. Let's run this once again. Now if I select the image and something with a lot of, so you see that every rectangle has some different color, red, green, pink, red, then again yellow. So this is the change I have made, and very small little change but looks good over here. Let's try to select something else. So here is a book, cell phone, and mouse. Let's try to select this. Is a blue, and this is a banana with 75% accuracy, and here's the cat with 73% accuracy. Alright guys, so I think it is enough for this video, and if you have any queries about this video, this project, this application, you can ask them in down comment section, and I'll end this video right over here. And if you found this video helpful, make sure you hit the subscribe button and share it with your friends, and also like this video. So goodbye, I'll catch you in the next video.